Hello, in this video we're going to give all the hints on assignments 1 and 2, which was a 4-page packet in our class. So let's get right to it. All these problems are about trigonometry, and actually I added the third learning target, which we already are really doing, but it just wasn't printed. So what we're really doing here is we're using trigonometry to solve applied problems. Those are like the word problems. The first problems, though, actually aren't word problems. They're just straightforward trig problems where you're trying to find a missing side. So notice how all the things here are missing sides. And to give you a major hint, all of these are actually going to be tangents. So you're going to say something like in number 1, the tangent of 41 equals x, whoops, equals 12 over x, and then you'll solve for x. How do we know they're tangents? Is because here's our angle, go across to find the opposite, and x is, or this side is the hypotenuse, and then this side is the adjacent. So in all these problems, if you notice, we're always dealing with opposite and adjacent for actually these four. And hopefully you're comfortable solving that. Please take a look at my Learning Target 1 video if you want to see how to solve problems like this. Now, in these ones, these are really good word problems. Let's get in. Let's see. Find the tangent of the larger acute angle. So they want the tangent of the larger angle. So what they really just want is the tangent of a larger angle. We'll call it the tangent of angle A in a right triangle with sides 3, 4, 5. So let's just sketch that triangle. So of course 5 is the hypotenuse. We'll make this side 3 and 4. Okay, so which one of these two angles? Would it be this angle up here or this angle down here? Which one would be angle A? Well, you really have to think which angle is more open. The side opposite will be larger. So the 3 or the 4? Well, the 4 is larger. Which angle is creating this 4? It's got to be this. This is the larger angle. So this angle down here is actually the smallest angle because it makes the 3. So they just want the tangent of angle A. Well, what's the tangent of angle A? I'll let you finish. Now, this question B says, we kind of did a whole warm-up on this in class this year. For what angle is the tangent of an acute angle? And pretty much all of our angles that we're dealing with in trigonometry are acute because they're almost all less than 90, right? In a right triangle. I mean, they really are all less than 90 in a right triangle. Find the angle measure. For what angle measure is the tangent of an acute angle in a right triangle equal to 1? Let's just answer that question. So here's a right triangle. For what angle measure does this tangent come out to be 1? Well, it takes a little thinking. What is tangent? Tangent is opposite over adjacent. When would this fraction be equal to 1? Well, it would be equal to 1. A fraction is equal to 1 when the numerator and the denominator are the same, when you're taking a number and dividing it by the same number. So when the opposite side and the adjacent side are equal lengths, right? Because that makes it be 1 for the ratio. When these are equal lengths, it's 1. So what angle right here makes these be equal lengths? Oh, well, if these are equal lengths, then these are equal angles. And if these two angles are equal, ooh, well then that's easy, because these two plus the 90 have to be 180. And we'll leave that question there. However, I really want to make sure everybody understands. We're really looking for how much is that angle measure that makes the tangent be 1. That's the first question. And the second question is, what angle measure makes the tangent be greater than 1? Well, that'll just be an angle measure that's greater than A. And what makes the tangent be less than 1? That's a measure that's less than A. So what is this angle measure that makes the opposite and the adjacent be the same? That's what I'm really looking for. And that's the answer to the first question. For what angle measure? Now in this problem is long because it's asking for the perimeter of this figure. So you have to think, how long is this side, and you have to add up all these pieces. This little piece here, CG, this piece, and this piece here. what's given to you is that A to C is 26. So this whole line here is 26. And then it also says that AD is equal to BF. So this line equals this line. And finally, it says D is the midpoint. D is the midpoint of AC. So that means that, oh, this piece also is equal to this piece because D is the midpoint. So this piece, and this piece over here, all three of these pieces are equal. And A to C is 26. Well, if A to C is 26, then this is 13. And so is this piece 13, and so is this piece 13. And then you can start solving all these missing pieces. This will just be a normal trigonometry problem. You can find this length and this length. You can find this length because you know this angle is 35 and this whole side is 26. Now to find this length, you need an angle in here. We know this side is 13. What's this angle right here? Well, notice how they marked all three of these angles the same? So maybe we could find one. We can find this one because it's in a right triangle where we know 35 and 90, right? So 35 plus 90, take it away from 180, and you'll find this angle. All three of these angles will be the same. And then you can do trigonometry on this problem because you know the angle and you know this side. And you can find these two missing sides. And you know this angle and you know this piece is 13, so you can find this missing side. You'll need to do and find this whole long missing side. And you'll also need to find this piece right here in order to find this last little piece right here. So you really have to think about adding and subtracting lines there to find CG. This is of course 13, and we talked about these pieces. So there you go, add up all those lengths. That's this problem. Now these problems are fortunately very straightforward. It just says find the value of each variable using sine and cosine. So this is going to be where you just go to the angle and you say, hey, here's our angle, label opposite, label hypotenuse, label adjacent, and make a little equation, solve for x, and then also do another little equation and solve for y, and that's it. Round your answers to the nearest tenth, so that means that if you get an answer like 13.86, that rounds to 13.9 because that's tenths place. So that's all these problems. Now these ones are very similar, except they say solve the right triangle. So what that means really is that means find all angles and find all the sides. And that might sound tedious, but remember, you can use the Pythagorean theorem. So you could say for this problem, if you want to find this piece right here, AB, the hypotenuse, you could say, oh, 9 squared plus 12 squared equals that piece. And there's another tool you can use. Now, in addition to using the Pythagorean theorem, a squared plus b squared equals c squared, to find this missing side, of course, remember, you can also use inverses to find missing angles, because you do have to find all the angles. So to find this angle, you would label opposite from the angle, and adjacent, and hypotenuse, and you do an inverse. Hopefully that's comfortable for you. And so you can use inverses, you can use the Pythagorean theorem, you can also use normal, sine, cosine, tangent, and pretty much all you have to do is find all the sides and angles. And those are that's set 4. Now for set 5, there are a lot of word problems. The first one says, draw a diagram and show the approximate dimensions of your ramp. You really need to read this problem and just draw a triangle and find the sides and the angles. So really, it's the same as these problems, where you find all the sides and all the angles. It's just one triangle. And they're telling you one angle of it and one side of it. And you just got to draw it and go from there. So draw the triangle, label the angle and the side, and find the missing sides and angles. Now, these, you might be frustrated I didn't give you very many hints last problem, but this problem I'm going to give a bunch of hints on. So let's get right to it. It says the horizontal part of a step is called the tread. So that's the sideways part, horizontal. The vertical is called the riser. I'm just reading. So that's the red part. The recommended riser to tread ratio is 7 to 11. So that's riser to tread. So what they've effectively just done is told us, look, this riser is 7 and this tread is 11. And they just told us basically that triangle. And it says find the value of x for stairs built using this recommended tread ratio. So how would we do this? Well, there's two ways that I kind of thought about this. One way is you could realize, and it's a little tricky, but if you kind of sketch the rectangle that this lies in, it becomes a little more clear, sort of. And that you'll see that this angle is actually the same as this angle. So you could go and find this angle in here, which would just be a simple inverse tangent, because this is the opposite 7, the adjacent 11. And there's your answer. Another way to do this is, if you don't like all that, is to say, hey, if this is 11, this is 11. If this is 7, then this is 7. And then you could say this is a right angle. You could do an inverse trig problem here, and you could find this angle, and then subtract 90 to find the leftover x angle. That would also work. I think it's a little easier to do just x from up there because those are the same, but you really had to have a little bit of creativity to see that. You want to build stairs that are less steep than the stairs in part A. Give an example of a riser to tread ratio that you could use. I like this question. What would be another ratio? So 11 to 7, cool, that's a ratio. We want a ratio that's less steep. So what would be a less steep ratio? Good question. In this problem, they're saying solve both triangles. So they want all the sides and angles. So how would we do this? Well, let's start with this angle and trying to find this missing side. That would be an opposite label. This is the hypotenuse of this little right triangle over here, and this is the adjacent. And so to find the opposite side, we could call this middle piece x. You could say, oh, opposite over adjacent, that's a tangent. And so the tangent of 41 equals x over 9, and you solve from there. Once you know x, you could use the Pythagorean theorem to find the hypotenuse, or you could just use cosine and say, oh, the cosine of 41, because cosine is adjacent over hypotenuse, so the cosine of 41 equals 9 over, and let's call the hypotenuse y, so 9 over y. And you could solve this problem from there. Just look up cosine and multiply by y on both sides, and then divide by the decimal. Now, to find this angle over here, or to find everything else you need, let's erase this stuff. Now, you got to think, how would you find these angles, right? So you have to find all these angles that are also in this situation, and you also have to find this piece. So I hope you realize that this angle is very easy right here, this first angle, because these three angles in this triangle will add to 180. Now, to find this angle, I don't think we can use 180. I think what we need to do is say, oh, remember how we found x? Well, now that we know x, we could say, let's work with this angle and say, oh, call this side the opposite, and call this side the hypotenuse. So this side will be the opposite of this angle, and this side would be the hypotenuse. And so you use this angle here, this opposite, and this hypotenuse, and you do an inverse, and it would be an inverse sine because it's opposite over hypotenuse. So you do a sine inverse of whatever you got for x. So whatever you got for x, you put that in here, and then 21 is the hypotenuse, and you do a sine inverse. And that would be this angle. And then once you find this angle, you can subtract from 180 to find this angle. And then once you have all that information, you can use a lot of different ways to find this bottom side ML. You could use Pythagorean theorem because you know x and 21, or you could use a normal trigonometry, sine, cosine, tangent, because you know all the angles and you know two sides. You have a lot to choose from. This problem D is a little bit of a challenging question, but not too bad. The perimeter of a rectangle is 16. The ratio of the width to its length is 1 to 3. Okay. And segment BD divides the rectangle into two congruent triangles. So that's the diagonal, because how else would you take a rectangle and make two congruent triangles? Well, you just got to slice it like a sandwich. So that's what they're talking about, B to D. So here's rectangle A, B, C, D. Find the side lengths and angle measures of those two angles. So of those two triangles. So they're really asking, hey, let's call this piece X. How much is it? Let's call this piece Y. How much are those two sides? And how much is this angle? We'll call it theta. And this angle, whatever. You can find that in a moment. So how would you do this? That's a little bit tricky. But what do they tell us? They tell us the perimeter is 16. And they tell us the ratio of the sides is 1 to 3. The ratio of the width to the length is 1 to 3. So width to length is 1 to 3. Well, what did we put for the width? Well, we kind of put for the width, we can call that x. And then we put for the length y. But what I'd like you to see is that we really could call the length 3x. And that's really the key to unlock this problem, is to call this piece 3x because of this key about the ratio. And I hope you can keep this strategy in your mind, because this type of strategy where they give you a ratio and then you label one piece like a variable x and the other piece 7 or 3x, that's a great strategy, because that comes out in a lot of problems across all of mathematics. All right. Now, what would we do now? Now you could do a crazy inverse with the variables in there, and actually the variables would eliminate inside the inverse in the fraction. But probably the more safe explanation or safe strategy would be say, hey, if the perimeter is 16 and this is x and this is 3x, oh, then this is x, this is 3x, and we could do a little old school problem from earlier in our semester and say, oh, that perimeter has to be 16, right? Oh, so this is x and 3x is 4x. Another 4x makes 8x equals 16. So therefore, in this problem, x equals 2. So, oh, x is 2. This piece would be 6. Now it's easy. You can do an inverse to find this angle. And that last angle up here is also super easy because it's 180 or another inverse. Okay. So in this last problem, let's get to it. Write an expression that can be used to find the measure of the acute angle formed by each line and the x-axis. Then approximate the angle measure to the nearest tenth of a degree. Well, they're really just asking you to find, they're saying, basically what they're saying is write an equation, write an equation, but they call it an expression. Basically, write an expression, write something that will let you find the angle made by the line and the x-axis. So let's just do A. So you first have to know how to graph this. Y equals 3x is a y equals mx plus b, a good old linear equation where the starting value is actually this is like y equals really 3x plus 0. So we start at 0, and then the slope is 3 over 1. So we graph the line. So we would go up 3 steps and go over 1. And it would be some line like this with a slope of 3 over 1. Now the slope is really important because what are they asking us to find? They're asking us to find the measure of the acute angle formed by each line and the x-axis. So they're really asking us to find this angle, the angle formed by the line and the x-axis. How would we do that? Well, let's say here's our line, right? And I think about a triangle. Do we know this triangle? Yes, we do. That triangle depends on the slope. Look at this. This is like the opposite side. But really, it's also like the traditional rise or the change in y. Remember how slope is rise over run. Well, that's right here, 3 over 1. That's the change in y. It rose up 3 units for every 1 unit that it runs over. There is our slope right there. So slope is a ratio of how fast the y changes compared to the x. This is changing 3 for every 1. Pretty steep line. Well, once we know that, it's so easy to find this angle right in here because you could just use a simple inverse. Spectacular. Now, the next question, very similar, right? Let's enjoy this last question here. What's happening? It's pretty cool. Well, I started to do this one. It starts at, so we graph it. It starts at 4, right? So we go up 1, 2, 3, 4. It's going to start right there at a height of 4. And then it's going to have a slope of 4 over 3. So if we graph the line, right, this piece would be, it would write, oh, I'll make that better. Should actually be a little more steep because I'm just realizing that the rise is 4 and the run is 3 because it's 4 over 3. So, cool, there's 4 over 3. Now, where is the angle formed? It's actually technically not this angle, although that would make the same angle. They're really looking for, here's our line. They're asking for the angle formed by the acute angle and the acute angle formed by the line and the x-axis. So they're asking for this angle. But yeah, like I was saying, it was the same as this, so I'm hopefully not wasting your time too much. But they do want this angle, but it'll be the same as this angle. So you would just do another inverse, which is 4 over 3. It'd be an inverse tangent because it's opposite over adjacent. So you'd say tangent inverse of 4 over 3, and there's your answer. Well, I hope you found all these hints helpful. Good luck finishing this assignment. Please send me questions if you have them.